Hello, my name is Dr. Steele, and welcome to Steele Mathematics, where lessons in Algebra 1, Geometry, Algebra 2, Pre-Calculus, and Calculus are taught. Let's talk about some money. Here's the situation. Let's say you decide to put some money into your account and you want to leave it in there for a certain number of years. After a certain number of years, you're going to end up with more money than what you actually put in your account. How much would that be? Well, it depends on the interest rate and how many times per year that the interest is compounded. Therefore, today we're going to talk about compound interest. And how much money you're going to have after a certain number of years, that's what we're going to find out. Let's say you put in P dollars in an account that has an R% interest rate and compound it N times per year for T years. The amount of money accumulated after T years is found out by using this formula. And by the way, P is called the principal. It's how much money that was put into the account. Now, there's terminology that describes how many times per year that the interest is compounded. If the interest is compounded annually, that means it's compounded once a year. Compounded semi-annually, twice a year. Quarterly, 4 times a year. Monthly, 12 times a year. Weekly, 52 times. And daily, 356 times. So with that being said, let's look at some examples. You want to put $600 into an investment account that has an interest rate of 12% and compounds quarterly. How much money will be in the account after 10 years? And now you're going to round it to the nearest cent. Well, let's see what we know. We know P is 600. The interest rate is 12%, and we're going to go ahead and change that into a decimal, which is 0.12. Compounds quarterly. That means N is 4. T equal 10 years, and we are looking for A. So now we're going to apply the formula. A equals 600 times 1 plus 0.12 over 4 raised to the 4 times 10 power. Now we're going to simplify this a little bit more. So we have 600, 1 plus 0.12 divided by 4, and that's 1.03 raised to the 40th power. 4 times 10 is 40. So now we're going to enter this into the calculator. 600 times 1.03 raised to the 40th power. So A is 1,957.22. So therefore, the amount of money you're going to have left in the account is 1,957 $957.22. So now let's look at the next example. You put $400 into an investment account that has an interest rate of 13%. If the account is compounded semi-annually, about how many years will the money accumulate to 1,000? Round to nearest whole number. Okay, so let's see what we know. We know that P is 400. R, the interest rate, is 13%, so we're going to change that to a decimal. It's compounded semi-annually, which means N is 2. And it asks you how many years will the money accumulate to 1,000, so we know A is 1,000. And we are looking for T. All right, so we're going to apply the formula. 1,000 equal 400 times 1 plus 0.13 over 2 raised to the 2th power. All right, the first thing we're going to do, we're going to isolate the exponent. So we're going to divide both sides by 400. $1,000 divided by 400 is 2.5. And we're going to go ahead and compute what's inside the parentheses. So we got 1 plus 0.13 divided by 2. That gives you 1.065. So this is 1.065 raised to the 2th power. So now what we're going to do, we're going to use the definition of logarithms to rewrite this. So 2t equals log base 1.065 of 2.5. Divide both sides by 2. This will be log base 1.065 of 2.5 divided by 2. Now, your calculator will not have that log notation function on it. So what we're going to do is we're going to apply the change of base property, which is also known as the calculator property, to rewrite this. So this will be log of 2.5 divided by log of 1.065, all divided by 2. We're going to apply this to the calculator. Log of 2.5 divided by log of 1.065 divided by 2. And you will get about 7. They want you to round to the nearest whole number, and this will be 7. Therefore, it will be about 7 years. So you see what happens where the interest is compounded a certain number of times per year. But now let's see what happens if it's compounded continuously. This would be a different formula. Let's say you put in P dollars in an account that has an R% interest rate and compounded continuously for T years. The amount of money accumulated after T years is, you'll find that using this formula. This involves the E function, as you can see here. So let's look at a couple of examples. You put $100 into an investment account that has an interest rate of 13%. If the account is compounded continuously, how much money will be in the account after 15 years? So let's see what we know. We know P is 100. R is 13%. We're going to go ahead and change that to a decimal to 0.13. T is 15. And we're looking for A. Now remember, this is compounded continuously. So the formula, we're going to apply the formula. A equal 100 E 0.13 times 15. We're going to go ahead and multiply 0.13 by 15, and you will get 1.95. So in your calculator, this would be 100 E to the 1.95, and that'll be 702.87. Therefore, the money that will be in your account after being compounded continuously for 15 years will be $702.87. So now let's look at another example. You put $500 into a savings account that has an interest rate of 14.7%. If the account is compounded continuously, how many years would it take to accumulate to $1,500? You go round to the nearest whole number. So let's see what we know. We know P is 500. The interest rate is 14.7%, so that would be 0.147. And after so many years, you have $1,500. So A is $1,500. Therefore, T is what you're looking for. So now we're going to apply the formula. This is 1,500 equal 500 E 0.147 T. So now we're solving for T. We're going to isolate the exponent. We're going to divide both sides by 500. You'll get 3 equal E to the 0.147 T. So now what we're going to do is we're going to use the definition of logarithms to rewrite this. So this is 0.147 T equal natural log of 3. Divide both sides by 0.147. And this is what you're going to enter into your calculator. So natural log of 3 divided by 0.147 gives you about 7.47, which is about 7. Therefore, the solution is 7 years. So what we have learned today are basically two formulas. It depends on if the interest is compounded a certain number of times per year or if it's compounded continuously. I hope that you have a wonderful and blessed day.